Hello, this is Mr. Dutta, and I will be narrating the thermal energy transfer module. I am just going to read all the text that is present, and you can follow along, pause it, rewind as many times as you wish. So in the introduction, it says the big question, what makes something hot or cold? How do things get warmer or cooler? To answer these questions, you'll explore how heat moves from warmer to cooler areas through the transfer of thermal energy. All matter is made of particles that are in constant motion. This energy of motion is known as kinetic energy. All particles do not have the same amount of kinetic energy, so when we measure temperature of a substance, we're finding the average kinetic energy of its particles. The thermal energy of a substance depends on its temperature, as well as the quantity of particles it contains. A cup of water and a pool of water may both have the same temperature, but the pool contains more thermal energy because it contains a lot more water. Thermal energy flows from warmer areas to colder areas. Heat is a measure of this flow. This transfer of thermal energy can occur in three ways: conduction, convection, and radiation. Conduction transfers thermal energy through direct contact. Thermal energy from faster moving, warmer particles is transferred to slower moving, cooler particles. Some materials, such as metals, are better than others at conducting thermal energy. Convection transfers thermal energy by the movement of fluids. Convection transfers thermal energy through the flow of particles in a liquid or a gas. The movement of the heated materials carries energy away from the heat source. Radiation transfers thermal energy through electromagnetic waves. Radiation can carry thermal energy from object to object, even through empty space. When the waves strike a material, the particles in the material absorb energy and move faster. Some materials are better than others at absorbing energy from radiation. For example, dark surfaces are better at absorbing thermal radiation than light-colored surfaces, and rough surfaces are better at absorbing thermal radiation than smooth, shiny surfaces. All objects absorb and emit thermal radiation. The sun warms Earth. So these are a series of questions that you'll be answering on the worksheet, but I'm just going to narrate what each of these buttons says. So if you click on conduction, the sun warms Earth. Most conduction occurs at Earth's surface. During the day, solar radiation warms the ground and water, which then heats up the air touching them. Air is not a very good conductor of thermal energy, because the particles in the gases that make up the atmosphere are far apart. For convection, the sun warms Earth unevenly, and the areas near the equator are heated more intensely than the polar areas. Convection currents in the atmosphere distribute thermal energy around the Earth. Global ocean circulation also distributes thermal energy around the Earth. Mantle convection carries thermal energy from the Earth's interior to its surface and drives plate tectonics, causing phenomena like earthquakes and volcanoes. And radiation. Number 1, the sun is Earth's main source of thermal energy. Radiation from the sun travels through space and warms Earth's atmosphere and surface. Number 2, some solar radiation is reflected back towards space by clouds in Earth's surface. Number 3, Earth also emits thermal energy into space. And number 4, greenhouse gases trap some thermal energy in the atmosphere. Around a campfire. So conduction. Number 1, a metal rod would not be a good choice for roasting marshmallows because metal is a good conductor of thermal energy. It would quickly become too hot to hold. Number 2, a tree twig would be a better choice because wood is a poor conductor of thermal energy. Convection. As the air around the campfire is heated and becomes less dense, it rises and moves upwards, creating a convection current that transfers heat. You can see this natural convection as smoke rises from the fire. And radiation. Thermal energy radiates from a campfire. The warmth you feel when sitting near a campfire is primarily from the transfer of thermal energy by radiation. The marshmallow held near the fire also gains thermal energy from radiation, which toasts the marshmallow. Staying cool on a hot day. So, conduction. Conduction takes place at your skin's surface as thermal energy is transferred from your body to the air or anything in contact with your skin. You might prefer standing on a tile floor rather than a rug. Tile is a better conductor of thermal energy, so it's easier for heat to flow from your feet into the tile. The conduction makes the tile feel cool. Convection. When your body is too hot, it increases blood flow to your skin, where heat loss occurs. You may prefer to be on the ground floor rather than upstairs because warm air rises through convection. Where the air is cooler downstairs, more thermal energy will transfer from your body to the air. A fan increases the flow of air in a room and can help increase the transfer of thermal energy from your body to the air. Moving air increases the rate of heat loss from the evaporation of sweat. And radiation. Radiation from the sun transfers thermal energy to a person standing in sunlight. Staying in a shady area can help keep you cooler on a hot day. Your body also loses thermal energy to the environment by radiation. And last one. How can your house be designed to take advantage of ways that thermal energy is transferred? We'll start with conduction. A home loses thermal energy to the colder outdoor by conduction through the walls, windows, and roof. Adding insulation can help reduce this heat loss. Fiberglass or blown cellulose, which are poor conductors of thermal energy, can be installed in walls and ceilings to slow down the loss of thermal energy. Double-paned windows made of multiple layers of glass, with gas trapped between them, offer more insulation than single-pane windows and can also make a house more energy efficient. And convection. Convection transfers thermal energy throughout a house by air movement. Gaps between building materials create air leaks, places where air can flow into or out of a home. Because warmer air rises through cooler air, heat loss is generally greater from air leaks near the roof than around doors or windows. Homes can use convection to distribute warm air from a sunroom, which is warmed by solar radiation, to the rest of the house. A solar chimney, which is heated by solar radiation and creates an updraft of air, can enhance the ventilation of a home. Fans and pumps can also be used to create forced convection. And radiation. A home loses thermal energy to the colder outdoors by radiation. Solar radiation hitting the house or windows can also help warm it. Special coatings on window glass can reflect radiant energy to help keep a house warmer in the winter and cooler in the summer. Solar radiation can also provide energy for other uses. Photovoltaics, also known as solar panels, convert sunlight into electricity, and a solar hot water system uses thermal energy from the sun to heat a water tank.